Alright, welcome everybody to a new video. This will be about an idea that I had in mind for quite a long time, and it's called the electro candle, or the infinite candle if you want. It was originally meant to be a gift for a girl, and the first prototype, which I'm going to talk about, failed completely. And, well, this one here, which is the second attempt, is quite a lot better. Now, the idea is that of a candle that you can recharge, in a sense, and remake as many times as you want. So that's why it's infinite. The essence of this idea was, all right, I want to find a way so that I can do all of this sitting on my chair and do it on my desk in about 5 or 10 minutes. I don't want to get up, use fire, melt the wax. What if I stumble and then all the wax is, I just want to sit down and do this in a very calm way. So the idea is the holder itself and maybe something else around it will allow to melt the wax into a new candle. So it's the holder itself allowing for the process of making a candle. Now, the first prototype was kind of a disaster because I thought about it this way. Like you have this aluminum disc sitting at the bottom of a wooden container like this. And I had to put resistors in contact with the disc, thermal paste in here, and a bunch of wires, a connector here, an LED, and so on. So that looked absolutely awful and not suitable for a girl. If you don't have a continuous container for the wax, then once the wax is melted, it likes to escape from every possible crevice and holes, and actually it sweats through the wood itself. So then I come up with this new prototype, which is just a steel container and an olive wood holder. And I thought about it like, I don't want to have more than a candle holder. Like, I don't want to see wires and switches and thermal paste and resistors and all of it. Like, I want to have something that has this artistic touch that you could put on every surface in every room and use in every occasion. Then a possible solution is induction heating. So the idea is I have my candle now, and I can put it on top of a wooden plate with a coil hidden inside of it, and this coil is driven by the induction heating module, which of course needs a power supply as well. And the way this works is there are going to be very high currents, like 30 or 40 amps, and they alternate at a frequency of about 15 kilohertz, something like that, maybe a little more. So then, of course, current always has a magnetic field associated to it, and so you're going to have a strong and alternating magnetic field that's going to cut through the steel here and heat it up. So effectively, this is a wireless transfer of power, and that's very cool because then the steel piece here is heated uniformly. Now, I know this is like complex, way too complex and fancy, but that's just, I'm having fun, right? Because yes, you could just melt the wax and pour it inside of here, and that would be absolutely fine. But, this way you can actually sit down and do that without fire involved, just flicking the switch and waiting about 3 or 4 minutes. That's it. Okay, so now I will show you all the electronics, the circuitry, and a quick demonstration. This is a raw prototype that I built in about 30 minutes in my shed, and it's like not the way I imagined it to be. So if I had to give it to her, I would have to work on this, sand it down, and turn it into a very beautiful wooden plate with the coil inside, hidden inside of here. And this, which hides the circuit, of course, would have to be way better. Like the fan would have to be inside, and the wooden box would have to look way better than this, like sanded and polished and all of that. And I would have to add a grid maybe here and all of that. So this is just a raw version that I built in here, very quick to show how it works. Right, so this is a circuit, and I want to be very clear about this. I studied electronic engineering, but I haven't graduated yet, so I don't have any kind of experience, and I'm pretty sure that, well, this is not reliable at all, and there could be millions of ways to make this more efficient, probably with a microcontroller. But anyways, this is the driver. So it's a circuit, it's a power circuit that is able to generate the oscillation, and it's a kind of standard circuit, so you can find it pretty much everywhere on the internet, like Google Images or YouTube. I got the inspiration from Electroboom. This is a timer, so what it does, it counts up to 10 minutes and then it shuts down the driver, so it's a safety feature. And when that happens, the LED blinks. And this little circuit here is the safe starter. So a potential problem of the driver is if the power supply doesn't rise as fast, then the oscillation may not start, and the two MOSFETs might both be conducting and be shorted to ground, so they both die. And to make sure that the driver starts when the power supply is ready and fully on, this little circuit here delays the start. Okay, so this is the setup, and the meter is used to measure the current drawn from the power supply. And the candle is sitting right on top of the coil. Now, in reality, that would have to be separated from it by some thickness. Oh, shoot. Sorry. Actually, this coil here is not performing as good as this one. So, for simplicity and in order to obtain a quicker result, I will just put this right on top of the coil. So let's turn the circuit on. Hopefully the fan doesn't make too much noise. With load, 3 amps are drawn from the power supply. Without, it's about 1.7 amps. So I will put this on top of here and maybe close this. Well, in about 5 minutes or a little more than that, I should have the wax melted. Now, of course, with different voltages and different coils, the result might be quicker. Okay, so it's definitely too slow. So it's working. The wax is melting, but it's just too slow. And therefore, I will try to change the coil with this one here. Okay, so I'm cheating a little bit because I said the coil should be hidden inside of a wooden plate, but now it's actually wrapping around the candle. And the heating is way quicker. It's drawing 4 amps instead of 3. I'm pretty sure there could be the proper combination of supply voltage and coil shape and number of turns to make this work, even if the candle is sitting like on top of the coil and the coil is hidden inside of the plate. So there it is. It's now melting properly. And it only took like 2 or 3 minutes. So way better than before. I'm gonna add some wax. I'm stirring so that I can expose the wax to the hot surface. Okay. Now the timer kicked in, but it did it at the right time. So the circuit is off. The power circuit is off. Only the fan is working, so I may as well turn the whole thing off. Now, very carefully, there we go. And finally add the wick, maybe some drops of lavender oil. Mix that. All right, let me just cut it down a little bit. Okay. All right, so that's not the way to make a wick, of course, because they usually have a little aluminum plate at the bottom of them, but it's just a quick demonstration. It's good enough. I'm just waiting for the thing to properly cool down because I'm pretty sure that underneath the surface here, the wax is still liquid. All right, there it is, glowing in the dark.